Okay, let's take a little bit of a look about the efficiency between the two different algorithms in the previous program in order to find an element in an array. So the program here has been adapted so that I can set the array size to whatever I want. I've got a couple counters here measuring how fast the algorithms are going to be so that I can take an average. I've got this for loop running a 1,000 trials just to kind of get a good sense. I found that on 1,000 trials, the variability in the answer was like plus minus one, so that's pretty reasonable. I made an adjustment to the iterator here. So I'm using I for, you can see this in the two algorithms. And when you're doing this kind of this kind of simulation, you really want to remove anywhere where something is being displayed. So I've removed the search number display. I've removed whether or not the thing was found. I just care about how many times it took. And this is roughly the same formula as before, just sort of it'll allow it to scale based on the size of the array. Other than that, it's pretty much the same. At the end, what I'm doing is I am dividing how many times it took across all of the trials by 1,000, which is how many trials I had, just so that we can get an average. Realize the decimal is removed from this, but it'll still work well as an integer. And then this will give me the percentage difference between the two algorithms. Okay, so let's run this. This is essentially the same as what we had in the previous program. So I'll run this, and here's what I get. In the first algorithm, where we are just going through the entire array, and when we find the element, then we stop running the program. It takes, on average, about 68 tries to stop running. In the second scenario, it takes 51 tries because, again, as soon as it gets to numbers that are too high and it realizes, so it gets the additional knowledge that nothing beyond the number that you're searching for can be in the array because it's in sorted order, it allows it to end earlier. So on average, that one takes about 51 tries. So the percentage difference between the efficiency of these two is 23%. So this kind of makes sense because half of the time they both take the same amount of time if it's equally likely to find the element or not find the element. That's about 50%. So half of the time they both take 100 trials. And then the other half of the time, this first one goes all the way through all of the elements, and then the second one stops when the elements get too big. So half of the time it takes, this second one will be 50% more efficient. So if you do a 50% times 50%, you would get around a 25. And this is, we'll see what elements affect this number. So now, what will cause the efficiency in this one to either grow or decrease based on different inputs? So let's see if changing the size of the array matters. So instead of 100 elements, let's scale this up to 500 elements. Multiplying an input like this times 5 should generate a dramatic increase if it has an effect. So I'm going to run this, and then we'll see what happens. So I'm going to pull this up. Okay, so now the first algorithm takes, on average, 334 checks to verify if the element is there. On average, the second one takes about 250. So what we get here is actually pretty much no change. Any change in here is actually going to be as a result of my search num possibly not scaling quite as nicely as it should. So really, it does not matter what the size of the arrays are. This one is equally better no matter if you have 100 elements, 500 elements, 10,000, millions. So it doesn't, it's more efficient no matter how many items are in the array. So I'm going to return this back to its 100 because we have determined that the size of the array, in this case, doesn't have an effect on the efficiency of the algorithm. So now let's take a look at the likelihood. So in this element here, when we're picking the search num, it roughly gets it so that it's about 50% likely to find the element in the array. Now, what if we actually change this a little bit? What if we make it less likely? So if I multiply this by 2, that will create a bunch more numbers that won't be in the array, because now we're, this potentially could give us the number 201, which is much larger than like the maximum of our arrays are usually get to is about 150. So that'll put about 50 elements that we know guaranteed are not going to be findable. And let's see what happens with the percentage results. I'm going to run this again. And a multiply by 2 changes the efficiency. So you can see these numbers changed a little bit because it's closer to 100, so it made it, the second one is 17% more efficient. Now, if I go to times 5, which will be a dramatic increase, so this makes it very unlikely that the number will be found in the array, and it'll also cause the second one to have to go to some very large values in order to find what we're looking for. So I'm going to run that again, and the second one will drop dramatically to 6%. So this value has a big effect if we are looking for possibly elements that are larger than the array. Now, what if we change the variability to this value here? So if I change this to, say, a 3, so there's going to be more space in between the numbers. Let's see what happens. So if we're doing this, then the randomness will probably cause it to max out at about 200 or a little bit more. So in this case, I've got to scale this a little bit equally. So let's see what happens here. So by putting more space in between the elements, and we're still looking for a number in the range, our second one becomes way more efficient. If I go to an even higher degree and go to 2.5 here to scale it, it becomes even more efficient. So you can see a grand difference between these, 80 versus 51, which is starting to really increase the difference. So by taking a look at that, it gives you a little bit of a sense maybe what factors might increase the efficiency of one versus the other, but pretty much you can say that in almost all cases, the second one is much more efficient than the first one because an average of 25 is pretty significant.